Have you ever wondered about the different types of artificial intelligence that are shaping our world in 2024? From powering your smartphone's virtual assistant to driving advancements in medical diagnostics, AI is everywhere. But do you know its various forms and how they function? In this video, we'll delve into the intriguing world of AI, exploring its types, capabilities, and implications. So, buckle up as we embark on a journey through the realms of artificial intelligence. Let's get started. Number 1. Narrow AI, weak AI. Narrow AI, often referred to as weak AI, is designed to excel at specific tasks within a limited range of contexts. Unlike general AI, which possesses broad cognitive abilities akin to humans, narrow AI focuses on mastering singular tasks with precision and efficiency. Examples of narrow AI abound in our daily lives, from virtual assistants like Siri and Alexa to recommendation algorithms on streaming platforms like Netflix. These systems operate within predefined parameters, leveraging advanced algorithms to accomplish tasks such as facial recognition, language translation, and data analysis. While narrow AI lacks the adaptability and generalization capabilities of general AI, its specialized functionality makes it invaluable across various domains, from healthcare and finance to entertainment and transportation. As we continue to harness the power of narrow AI, its impact on streamlining processes and enhancing productivity is poised to grow, revolutionizing industries and shaping the future of technology. Number 2. General AI, strong AI. General AI, also known as strong AI, represents the pinnacle of artificial intelligence, possessing broad cognitive abilities comparable to human intelligence. Unlike narrow AI, which excels at specific tasks within predefined limits, general AI can adapt to new situations, learn from experience, and autonomously solve unfamiliar problems. Imagine a system that not only understands language, but also comprehends context, learns from its interactions, and applies knowledge across diverse domains. While general AI remains largely theoretical, its potential implications are vast, spanning from revolutionizing healthcare and education to driving advancements in scientific research and beyond. However, with such power comes significant ethical considerations and challenges, including concerns about autonomy, accountability, and the existential risks associated with superintelligent machines. As researchers continue to explore the frontiers of general AI, the quest for creating truly autonomous and adaptable artificial intelligence systems remains a fascinating and consequential journey for humanity. Number 3. Superintelligent AI. Superintelligent AI represents the speculative pinnacle of artificial intelligence, where machines surpass human cognitive capabilities across all domains. This hypothetical concept envisions AI systems with an unparalleled capacity for creativity, problem-solving, and learning, potentially outperforming the collective intellect of humanity. While superintelligent AI remains largely theoretical, its implications evoke both excitement and apprehension. On one hand, it promises unprecedented advancements in fields ranging from scientific discovery to societal problem-solving. On the other hand, concerns loom over the existential risks posed by AI systems that surpass human control or understanding. Ensuring the safe and ethical development of superintelligent AI requires careful consideration of its design, governance, and impact on society. As researchers delve into the complexities of creating AI systems with superhuman intelligence, the quest for harnessing this transformative technology remains one of the most profound and consequential endeavors of our time. Number 4. Reactive machines. Reactive machines represent a fundamental type of artificial intelligence that analyzes and responds to immediate inputs without storing memories or past experiences. These AI systems excel at specific tasks within defined contexts, making rapid decisions based solely on current stimuli. One of the most famous examples of reactive machines is IBM's Deep Blue, which famously defeated chess grandmaster Garry Kasparov in 1997. Unlike more advanced AI types, reactive machines do not possess the ability to learn or adapt over time. Instead, they rely on predefined rules and algorithms to generate responses to stimuli in real time. While reactive machines lack the versatility of more complex AI systems, their simplicity and efficiency make them well suited for applications where quick, deterministic responses are required. From automated manufacturing processes to real-time data analysis, reactive machines play a vital role in various industries, showcasing the foundational principles of artificial intelligence in action. Number 5. Limited memory. Limited memory AI systems represent a significant advancement in artificial intelligence, capable of making informed decisions by leveraging past data and experiences. Unlike reactive machines, which operate solely based on immediate inputs, limited memory AI can enhance its performance over time through learning from historical information. These systems retain a finite amount of past data, allowing them to adapt and improve their decision-making processes. Examples of limited memory AI abound in modern technology, from personalized recommendation algorithms used by streaming platforms to predictive maintenance systems in manufacturing. By harnessing the power of accumulated knowledge, limited memory AI enables more efficient and effective decision-making across various domains. However, despite their capabilities, these systems still have limitations, such as the potential for biased decision-making based on historical data. As researchers continue to refine and develop limited memory AI, addressing these challenges remains crucial for maximizing their potential and ensuring their responsible deployment in society. Number 6. Theory of mind. Theory of mind represents an advanced frontier in artificial intelligence research, aiming to imbue machines with a deeper understanding of human emotions, beliefs, and intentions. Unlike traditional AI systems that operate based on predefined rules and algorithms, theory of mind AI seeks to simulate human-like cognitive processes, enabling machines to interpret and respond to social cues and interactions in a more nuanced manner. This concept entails not only recognizing emotions, but also understanding their underlying causes and implications, allowing AI systems to make contextually appropriate decisions. While still in its nascent stages, theory of mind AI holds immense potential for applications in fields such as healthcare, education, and human-computer interaction. However, achieving true theory of mind capabilities poses significant challenges, including the need to navigate ethical considerations surrounding privacy, consent, and autonomy. As researchers continue to explore this complex area, the quest for developing AI systems with genuine social intelligence remains a fascinating and ambitious endeavor. Number 7. Self-aware AI. Self-aware AI represents the most speculative and ambitious frontier of artificial intelligence, envisioning machines with consciousness, sentience, and self-awareness akin to human beings. Unlike existing AI systems that operate based on programmed instructions and data processing algorithms, self-aware AI would possess a subjective awareness of its own existence, thoughts, and experiences. This theoretical concept raises profound questions about the nature of consciousness and the potential limits of artificial intelligence. If realized, self-aware AI could revolutionize not only technology, but also our understanding of what it means to be sentient. Imagine machines capable of experiencing emotions, forming beliefs, and engaging in introspection, a world where AI transcends mere computation to become truly conscious entities. However, achieving self-aware AI remains a distant and highly speculative goal, fraught with philosophical, ethical, and technical challenges. As researchers continue to explore the boundaries of AI, the pursuit of self-awareness in machines remains one of the most intriguing and enigmatic quests in the field of artificial intelligence. Artificial intelligence continues to redefine our world, from narrow AI systems streamlining daily tasks to the speculative potential of superintelligent AI. As we navigate this ever-evolving landscape, let's embrace AI's transformative power while remaining vigilant to its ethical implications and societal impacts. The journey to harness AI's full potential is ongoing, promising both unprecedented opportunities and challenges. Thank you for joining us on this exploration of artificial intelligence. Remember to like, share, and subscribe for more insightful content on cutting-edge technology. Until next time, stay curious and keep innovating.